Hello and welcome to the first video in probably quite a long series of tutorials which is going to teach you how to use the Arduino Nano RP2040 Connect. In this introductory video, I'm going to show you how to set up the Arduino IDE to program the Arduino Nano RP2040, as well as how to use the onboard RGB LED. By the end of this tutorial, you'll be able to blink the onboard RGB LED in different colours in order to use it as a simple indicator in some of your own projects, but also I'm going to show you how to fade between the different RGB colours in order to produce a nice sort of rainbow effect. All of the code that is written in this video can be found on my website, which is linked in the description. So, if you haven't set up the Arduino IDE yet to program your Nano, you can do it quite simply. You need to install the board package which corresponds to the Arduino Nano RP2040 Connect. To do this, go to the Tools menu above, then Boards, then select Boards Manager. In the window that opens, search for Embed OS and install the package that is called Arduino Embed OS RP2040 Boards. This might take a few minutes, but once it's done, you can close this window. Make sure that your board is plugged in over the micro USB connection. Then you need to select the COM port that it is connected to. To do this, go back to the Tools, and then where you see ports, select the port which is normally COM with a number after it, which will have the label of the Arduino Nano RP2040. These steps are done very similarly if you are using the new Arduino IDE 2.0 beta version. But however, I've had some issues with this recently, including an update that just broke it completely. So for stability and, simplicity, I suppose, I'm going to be using the v1.8.13 version of the Arduino IDE. However, this tutorial and all the code written inside it will remain valid if you wish to use this updated version. So that's the Arduino IDE set up and ready for us to use in our project. So let's get started with using the LED. First, let's take a look at the schematic of the Arduino Nano RP2040 Connect. You can find this on Arduino's website. For those unfamiliar with electronic schematics, they are actually a lot simpler than they look, and they form the basis of how to solve many electronics problems. So working out how to program certain boards. It's quite important to get your head around them as you get started learning how to program. I'm simply looking for the RGB LED, which can be found over here. And we can see that the RGB LED is simply 3 separate LEDs that are all connected to the same power source on their anode, or the positive side of the diode. And the negative sides are connected to a corresponding pin labelled LED B, G, and R, signifying their colours. If we have a look at where these labels are actually connected to, we can see they are connected to pins 16 to 18 of the U-Blox NINA module, which is the Wi-Fi and Bluetooth chip on board the Arduino Nano RP2040 Connect. So in order to use the RGB LED, we're going to have to go through this Wi-Fi module. Now, whilst this sounds quite daunting, if this is your first program that you're creating, it's actually quite straightforward, as there's a library that already exists for us to use this function. So go to the Sketch menu in the top of the Arduino IDE, then Libraries, and select Manage Libraries. Then search for Wi-Fi NINA and install that library. Now, at the start of every sketch that you want to include the LED on, you need to include the Wi-Fi NINA header file using the following line. We also need to set these pins as output pins, and we do that in the setup function using the straightforward pin mode function, whose arguments are the pin name, in this case LED R, G, or B, and then the direction, which is simply output in all capitals. We need to repeat this line for each of the 3 LEDs. And now we're ready to use them in our program. I'm going to write a very crude program to alternate the colours of the LEDs to basically blink between the different colors. However, in your own projects, you might want to change these lines around a bit to signify different events, say when you press a button or connect to a Wi-Fi network, for example. To switch the LED of a corresponding color on, we use the digital write function with the corresponding LED label and then use the high argument to turn it on. I'm going to start with the red LED. Then we need a short delay, and we implement this using the delay function with the number of milliseconds that we want the program to pause for. Then we turn the LED off using the digital write function, again with the pin number that we want to modify, but this time we use the low argument, which switches the LED off. I'm then going to copy and paste these lines twice more and edit the green and blue LEDs into the respective digital write function. There are more elegant ways to do this. It doesn't really matter, as this is sort of an indicator for use in your programs. So you can now build and upload the sketch, and you will see that the RGB LED is blinking red, then green, then blue, over and over. So hopefully this has shown you how to use the RGB LED in your projects, and we can of course mix these colors by turning 2 on at the same time, or making a white light by turning all 3 on at the same time. But let's say that we want something a bit prettier and smoother. I am now going to show you how to write a slightly more complex program, which takes advantage of the fact that by driving the LEDs with a PWM, or pulse width modulation signal, you can actually change their brightness. So right now I've got a very simple sketch on the screen, which is showing you how which simply uses the analog write function instead of the digital write function to change the PWM duty cycle between 0 and 255 to pulse the LED smoothly. Confusingly, a duty cycle of 0 actually means that the LED is at its brightest, and when at 255 the LED is disabled, although in my testing it's not quite disabled, it's just very dim. And this is because the RGB LED has a common anode, meaning that when the duty cycle is 0, a potential difference across the LED occurs, and the LED therefore lights up as a current can flow. However, when at 100% duty cycle, no current can flow through the LED. As you can see, the blue LED is pulsing smoothly now, and as a reminder, the source code of all the stuff written in this video is available on my website, linked in the description. This next sketch that we're going to do, sort of a third sketch, will explain a little bit more about how the pulsing of the RGB LED actually works. I just don't want to repeat myself twice. The third sketch that we're going to write will constantly cycle through the RGB colours whilst mixing 2 colours together. So for example, the intensity of the red LED decreases whilst the intensity of the blue LED increases, which creates a nice fade from red to blue. And this cycles throughout the sort of from blue to green, and then green back to red, and so on. So to start with, we're going to set up the code exactly like the others by including the Wi-Fi Nano library and setting the RGB pins as outputs. We're then going to define some integer variables, and these are just going to help us keep track of what's going on during the main loop. First is going to be an array of 3 values which correspond to the RGB values at any given iteration of the loop. The first number indicates the red value, the second is the blue, and the third is green. We're going to start the program with red at its maximum value and green and blue at their lowest. I know this is inverse to what I just mentioned about the common anode and cathode, but just bear with me, we sort that out later. Then we need 2 variables to track which colour is increasing and which one is decreasing, and I've called these variables up and down index. In this case, I will indicate that the blue LED is about to increase its value by setting the up index of the RGB values array to 1. And I will say that red is going to decrease by setting the down index value to 0. These numbers 0, 1 and 2 will indicate the position in the RGB array that we're modifying. So now that's all the setup we need to do. Moving into the main loop, we need to increase the value of the RGB, of the RGB color, which is increasing, and decreasing the one that is decreasing. Now I know that sounds obvious, but we can do this very easily by these 2 lines of code here, and this is executed each time the program loops. Then we need 2 if statements, which essentially switch the color that is being increased and the one that is being decreased. Say, for example, that red is increasing. Once it reaches its maximum value, it should stop increasing, and then it should begin to decrease at the next loop iteration, whilst the green LED starts increasing. To start with, let's deal with iterating the LED, which is gaining intensity. We create an if statement, which simply iterates the color index once the intensity reaches its maximum. Inside this if statement is another if statement which is used to wrap the index back to 0, or red, after it switches through blue. We repeat a similar if statement for the decreasing LED index as shown now. Finally, we use the analog write function to set the LED value every main loop iteration. In the value, we use 255 minus the current value of each LED. And this is because the RGB LEDs are a common anode, so when the analog value is 255, the LED is actually at its lowest intensity. So this essentially flips the working out in the main loops that we've just written. If you were using a common cathode LED, then you wouldn't need to do the 255 minus the LED value. You would just set each LED value as is. Then, finally, we're going to add a short delay of about 5 milliseconds to allow for smooth fading, and we are done. Now you can obviously adjust this delay if you feel like you want it to cycle through the colors faster or a bit slower. It's up to you. You can now build and upload your sketch, and you should see some nice LED rainbow fading. So this was the first video in a long series of videos about how to use the Arduino Nano RP2040 Connect. We're going to start with some introductory videos before moving into more complex videos. And so if you have any suggestions about things that you think would be interesting to cover, then do please let me know in the comments. I hope that this video was helpful for you. Please do let me know if you have any comments down below, and please like and subscribe. Thank you very much, and have a nice day.